Welcome back to Cloud Computing and Big Data, our short lecture 10 today. The title is Platform as a Service, and it nicely connects basically what we had before to the Infrastructure as a Service lecture that we had before. So we build now on this idea of having this scalable infrastructure and providing more platform components. And therefore, it makes sense also, of course, to look what we had the last time, which was indeed infrastructure as a service. So before we dived in this material of infrastructures, we also had a higher level view of this cloud service models, which is essentially today an inflation of everything as a service if you want. But there are three key terms in this course that you really need to know by heart. And this is infrastructure as a service, platform as a service, and software as a service. So this graphic here on the left-hand side also shows you this quite nicely. And you can interpret software as a service also as application as a service of some kind. Because here we're talking really, when we talk from the top to the bottom about applications, you're ready to basically swipe the credit card, you can use the application, and basically this could be enterprise resource planning, financial applications. It could be customer relationship management, CRM tools like Zoho, many of those that we will also explore in the next lecture, obviously. And they, however, are often built by cloud building blocks, or you would say, as if you remember, maybe in the first lecture, I introduced this interesting term, Lego bricks, right? So the platform gives you a lot of Lego bricks, and I think everybody's familiar with Lego, I guess. So, and these different Lego bricks you can build together to build your individual app, your individual software as a service application where you earn money with. Hence, we shift a bit the view when we go one step deeper to the platform as a service level, what we will do today, to review a little bit what could be this core building blocks that you need for a cloud application. It has a lot to do with data. I think that will be very obvious, right? You have to store data, work with data. An application without any database, no SQL data stores. We will talk about this, is not obvious to you perhaps yet, but an application with have no data at all is hardly possible. So hence today will be also a major footprint on databases, tables. Also, we look at the Google Cloud with some that you maybe already know, Bigtable and so on, and see how that relates and also to the web and so on. However, the last infrastructure as a service lecture was then really thinking about the base, and this constitutes really the hardware, right? So you can imagine this interesting flexible cloud that is hanging everywhere. Everybody can use it somewhere in the internet, is somewhere a functionality is possible, yes, but it is rooted by some really hardware underneath. So somewhere needs to be compute, somewhere needs to be a real storage or networking. And then you basically have this as a layered platform, and we learned a little bit that, of course, the boundaries between them are not really, let's say, very hard. You could consider some of these things, and let us review a little bit what we had the last time on EC2, where you say, well, EC2, the Elastic Compute Cloud interface and service that is really offered by Amazon as an example. Similar services are in MS Azure and the Google Cloud, as you will reveal today. These are basically the lowest level you can find. You can pick the service you need. You have done this now in many of the lectures, GPUs, CPUs, you pay the price for it. Then we had also the idea of S3, right? So having basically a bucket store for data, object storage as it is called. You don't care exactly where it's stored. You don't care exactly if it's a file here and there, but you have a key value where you drop something in the bucket and you want to get out of it, some data. And we talk about this a little bit more, how this is also supported on the platform level. But essentially, this is something where it's underneath really a key basic service constitute your infrastructure. However, the bucket store again, and when you look on the right-hand side, we said, this is just one object storage, there's block storage, as well, and then this file storage. You could argue this is already on the platform level, the AWS storage platform, as they say themselves, right? So it's really on the boundary of saying it's a low level, storage that we need, but it's also enabling us already as sort of a platform to really drop data as an object storage somewhere, maybe even with the Amazon Glacier, if you remember, also long-term storage with very interesting pricing schemes. So hence the boundary between them is not really hard, but you basically, if you see the lecture today, the platform as a service will nicely collect with this, and then you see also where you can draw a good boundary if you think and put more on the developer view. While the infrastructure as a service is a lot of administration of infrastructure, hardware provisioning, where do you put which services in the really, let's say, boiled down manner to real computing using perhaps virtualization a lot. This is something where you're on the infrastructure as a service level as an administrator, and we will change the view today to be much more a developer. So how do you do an app, in the cloud that is scalable, reusing this infrastructure as a service components? And by this, I just allude to what we said also with the MapReduce point. If you want to be developing apps based, on MapReduce, we will see that today, how that materializes. Several partners in industry using MapReduce on a daily basis, implementing MapReduce tasks. So they are in developer phase, but you could choose in the infrastructure as a service level. Do you do basically the MapReduce cluster on your own, in your own, let's say, cellar somewhere in an organization? And using virtualization then maybe a bit more, and use already installed MapReduce appliances that are there that you can download and then create instances out of it, which makes the cluster management a bit easier, still remaining maybe with your own hardware, still using a lot virtualization. And then you could draw the line and maybe moving out already towards other organization and ask for a MapReduce hosting for you. So you don't have the capital investment for hardware. You just let it host by someone else and use it. Obviously, this use maybe give you some costs, right? And when you then have a fully fledged service with a MapReduce as a service where you then have the whole stacks, basically we talked about also in lecture 9 last time that, Hadoop and the Hadoop distributed file system give rise to a large ecosystem of open source software. Some of that you already know, also connecting nicely to Apache Spark and the environment. So hence, this would be, let's say, moving from bare metal through virtualization more and more into the cloud level, where you just swipe the credit card, get MapReduce as a service, and many things are already implemented there. So in a way, also the idea of moving from infrastructure as a service more to platform as a service, and then with MapReduce as a service, almost as a SaaS. But of course, more on the infrastructure perspective. Hence, today we connect nicely with this as a platform as a service, and the best way to understand this is really putting on the view of a developer of clouds. So a bit maybe away from an administrator of hardware and infrastructure. Here now we talk about more application development. Hence, we will briefly discuss basically the different levels again, but then quickly come to the idea that there are lots of Lego bricks already implemented in cloud solutions. So there's no point of starting an app, for instance, from the basics and everything from scratch. The same is with machine learning. If you want to have a machine learning app of some kind, you basically have lots of Lego bricks which are already developed, and that's why we will look at the Google App Engine as one example and pick some of these building blocks in the PAAS level, right? So platform level that helps you developing. Of course, there are very, very many of them. I just pick here a few which really are very essential. I think, for instance, NoSQL databases, key value stores, document stores, and so on is a very important topic which should be in a university as well as a full course, right? So, and we can't do that really, but here we just go over Cassandra, HBase, and a couple of those prominent examples, which basically are not missed in cloud developments today. And of course, with all of that, we have the scalability in mind. So why we move to the Google Cloud, we really want to scale up maybe from 5 users, 10 users to suddenly 1 million in a year. Then you quickly leave the space of doing this on your own in your own cellar with a small server. Hence, you have to have a professional monitoring, professional failure management, and so on. And this gives you all this cloud app development, not only mentioning, these errors and faults, also the typical versioning, right? An app has a life cycle. We will discuss this a little bit And of course, app development, again, would be a topic that, today you can have a full course on it, not just one lecture, right? So bear with me that this is only a short lecture. I show you some building blocks on the PAAS level because it's important to understand, including some of the pricing models, to get the pointers that essentially today you just have everything almost implemented. You just have to put together the Lego bricks and add your little bit of delta if you want, your little bit of change. What is your unique selling proposition as an application? Maybe something like Angry Birds, which we would reveal today. But inherently, all the computer science topic, how to store data, how to compute, how to get graphics scalable to all this different million of users, this is all solved in the cloud today. And of course, if you want to use it, you have to pay the price for it, but you can also incorporate this nicely in your app, costs that you have for your users to download. So let's get started again very briefly, because in a way we reviewed this already, right? When I reviewed lecture 8, obviously lecture 9, sorry, then we were on the infrastructure as a service level already, talked about lots of virtualized IT resources on the boundary to PaaS. Now, basically, PaaS is then the idea of really changing to the development view. Maybe also thinking about, if you now look in the Cloud App 1, that you can here create on the right-hand side, that you have lots of, let's say, building blocks ready for building your own applications, as we discussed. And just to make the disclaimer that this is not only true for the Google App Engine, you have also lots of building blocks in Amazon again, and also in MS Azure and other cloud providers, right? We focus here perhaps a little bit on the Google App Engine, being quite strong with it and also having lots of development support. But of course, you can also implement this in other cloud vendors. So let's review this a little bit. When we look on the PaaS level, you can see this here quite nicely when you have the overview. What's inherently in the PaaS is usually some sort of access to infrastructure, right? So server storages and the networking, and of course some, let's say, really physical computing somewhere. But the emphasis is much more broad of saying we need to operate all of this, and we need lots of development tools, database management of top of the pure storage, business analytics, machine learning algorithms, and so on, before you come even to your complete hosted application apps that you basically development with PaaS. So we'll see many software development kits on that level of PaaS, right? Application programming interfaces, REST APIs you will work with. And of course, you can do this here and there with your favorite languages. You have Java, you have basically Python, Ruby, and so on and so on. So there's a lots of broad, let's say, development support that goes with a platform as a service level, and basically also lots of data management that goes alongside it. And just to give you an example, which probably everybody of you know, is Spotify as an app that probably almost half of the course, if not more, are using today, is fueled by this kind of idea of having the cloud services, building up, with the Google Cloud, with its different Lego pieces, a service that is really scalable, has huge volumes of content in Amazon S3 on the infrastructure level, right? But if you know, Spotify has also a very good user interface and moved really from a startup company, right? So this was really a small company in the beginning, and then now it has basically over and over more and more licensed songs that you can actually use. So this is a very good example that basically the idea here of having Spotify as a service is brilliant, but the overall idea of scaling to many different users, right, is basically by leveraging also other cloud vendors, right? So it's Elastic MapReduce from AWS, Hadoop, and Spark. This is also by Airbnb used in Spotify applications to access these songs. You maybe not really directly just limited to one cloud provider, right? We have the Google Cloud here with Spotify users, but also for some of the different services, AWS services are needed. So you can mix this nicely, having also, of course, this APIs available, REST interfaces, and this goes into the domain of software engineering. And so for people that want to be platform developers, app developers, here I have to say you have to also, of course, go to a proper course in software engineering, particularly on app engineering, but always think about that the most building blocks are already there in the cloud providers to make it scalable. And you have, I think, very good examples here of the Google Cloud in general. Also, IKEA retailers using Google a lot, and you name it. Now, obviously, down when you look in the Google Cloud, you have down on the basics again the infrastructure as a service level, right? To connect it nicely, what we had already basically in another lecture last time, where we said, okay, we focus a bit on AWS. Of course, Google Cloud has also VM instances, right? That you put it on different, let's say, CPUs. Here's an example of a very unique TPU, tensor processing unit, which is basically then a very unique idea of Google, but you have also, of course, typical GPUs and so on. And you see also there's a hourly price usually on all of these different, let's say, tools. And this would be very similar now. You have a VM instance. When you create your Cloud App 1, you see everything is a bit oriented in this development engine here from Google Cloud to this app development, where you then have, the whole idea of using also the infrastructure as a service in a scalable fashion underneath. So in this way, you actually have this kind of idea to support the development lifecycle, right? So I mean, firstly, you have the app engine that you build, you test, you deploy your apps, let it be Angry Birds or maybe Philips Lightning or other games, whatever you want to do. You want to upgrade this, you have a better version, better data and so on. And you develop this locally, but as soon as you want to scale up, doing basically app development all over the world, which you see is also quite nicely supported by the app engine here, you have to go to a professional cloud provider like the Google Cloud, for instance, that has lots of scalable infrastructure as a service resources for you at hand. Also on the data side to, for instance, basically accumulate lots of big data, what can be done when you have more users, for instance, or you have more levels, more game, franchises. Angry Birds is not just one game anymore. There are many games of it. So in a way, this is the idea of the whole development life cycle, scale to your users, without them noticing, of course, that suddenly, your capacity is going to an end. Then you use a cloud to expand on the infrastructure as a service level, as I meant here. But of course, the today idea is a little bit on this lecture here to think more about the Lego bricks here. So when we have this life cycle and we have already the infrastructure given to us, the app engine and the whole life cycle process that you can support with this Google App Engine is then also including this Lego bricks that you need to build these apps. And we will review now a couple of those, but also the whole idea of new versioning, monitoring the traffic, right? So how is your basically game used, or how is the app used? The version control, new versions coming online. So all of that is beautiful supported, and of course inherently highly scalable because it's basically been managed via the infrastructure as a service that you have also in the Google Cloud. And you can really scale up. I think we have discussed this. Is also one of the selling propositions of the App Engine, and there's lots of information if you want on the Google Cloud, App Engine webpage. And for those that are really into app development, I encourage you to go there. There's also actually some quite free credits if you want to play around and have first maybe small apps developed. And just to give you more examples and motivations why you should do this is maybe here some of these kind of examples that you see on the right hand side, right? So IT overhead that you usually have, and basically by storing your own storages, by storing your own computer connected to the storages and then compute the levels in the apps or whatever you do, you can cut a lot of costs. Because usually you have also some maintenance of people, right? So you have some administrators that have to have the infrastructure right. You need to have some software experts to maybe deploy MapReduce to work on the different versions. Then you have some people that have to know something about storage and how to scale up. You see also here scales to more than 30 terabyte without performance issues. So this is already some remark, right? So 30 terabytes is not 30 gigabytes. as you know, you can see clearly. So that means, in other words, you need already quite some good infrastructure to manage 30 terabytes, right? That's not totally obvious to do with a little hard drive somewhere that you can buy at Elco here or so. So hence, all of this should be, of course, giving you a good customer experience, because that's what you want to achieve, right? Because then the people will download the app, they will rate the app good, so that other users are more likely to download the app. And by doing so, you're really automatically scaling to millions of users instead of doing your own, app development somewhere without considering, basically the cloud offerings. Of course, needless to say, I always say the disclaimer, there is a cost to it, right? That you have to incorporate maybe in your pricing model from the app, but you are on the safe side when it comes to different, let's say, versioning and so on that we have discussed, but also then the scalable user experience. And here you see nicely when you have a mobile backend for some game, it does not important which one, you have this building blocks I was alluding to. These are the initial building blocks and Lego pieces you want to have. You need a game app, you need a game server. So what does it mean? You can use the app engine and a specific, data approach called Memcache and data store, and then another handling of a Firebase. And then all the operations that you have here of cloud monitoring, cloud logging, error reporting, tracing, what's happening with the whole operations alongside go also into the idea of creating and understanding how basically your game is used. And then you have different building blocks of really working with the data processing, the analysis, what's happening essentially with the app, and have some tools we also will review, like BigQuery and so on, publish, subscribe mechanisms to also understand then how you basically, let's say, no matter what the game is, you always need these kind of building blocks, right? So these are Lego pieces that usually the user don't see, right? But will experience in a scalable fashion, because we always will monitor. We will see where we're running out of capacity very early. Let's add automatically storage this night at 2 o'clock at night, so that we have still a lot of, data storage capacity to have 500 or 1,000 more user. So as this is, of course, a point in it, it's not only scalable, it's also many things are automated, right? So you don't have to deal with it and stay up at 2 o'clock at night and see, oh my God, my storage is running out for this particular app. Maybe we want to add something. So you can have policies in place and more storage is added, but of course you pay the price for it. And with this, it's also important to review this pricing options. I mean, there are several different building blocks. Again, we cannot focus on all of them. There are so many. Here are some of them. When you think about the networking, for instance, you have essentially here the point that we discussed with AWS as well. So maybe incoming network traffic is free, but migrating then to another cloud provider, having basically the data somewhere else, this free storage or basically free cost of transferring this offers you, of course, an easy porting to the Google Cloud. But if you want to do all your data out, you have to have 12 cents, right? Basically discouraging you again of getting the data out. So these are examples where you have to be sometimes careful. If you, let's say, pick Google Cloud in the beginning, then suddenly you want to port everything to AWS, all your data, all your elements, and so on. Then if you think about, specific services, and I mean, one thing you connect with Google is hopefully search, right? So there are lots of strong search services, Lego building blocks, right? That we basically can use and integrate in the app again for searching within your own application, or giving this opportunity to users to search in their own app. This is already basically available with different queries, with different APIs, as you see here. But there you go, right? If you want a high-performance search API in your app, you basically have then $2. So again, this Lego blocks, what I want to give you here as an example, is of course that you have basically, of course, no cost for the upfront, let's say, storage. You'd have no cost for developing a search API that is strong. But of course, using that comes here and there was a price. And these prices don't seem much in the moment, $2, or here 12 cents for transfer. think about that your app is running 24/7 and prices can accumulate. So be careful on that as well. So let us go into popular modern PaaS building blocks, and some of them indirectly I noted already when we had, basically big table and so on, but also one of the elements here I wanted to bring across in this short lecture today is a NoSQL databases as, Lego building blocks again. So these are incredibly often used, mostly also because they have a, let's say, a high read performance, right? So they're less on writings, or if you want, they have less constrained consistency models. If you want to write to a SQL database, you can do this, but there are usually lots of checks in place, basically in the SQL database, which makes it here and there a bit slow. But here we are really with this column data stores, NoSQL data space, interested in lots of read-only operations, maybe levels, right? That you have level data. You don't want to influence the level. The level is loaded for every different, user of the game. So there's lots of this is, basically just read oriented. And this enables us really increasing latency and good throughput instead of using traditional SQL databases. However, this gives me the opportunity to also say, of course, structured query language databases are still needed, right? But, not maybe for every app development. So, of course, here it's again a kind of building block that is, required by few. And here should be nothing saying that SQL data stores are not needed anymore. Of course, I bring you an example here with Philips. I mean, many of you know this Philips Hue, I think, this kind of idea of Philips Lightning with apps very much improving your home experience with lots of Lightning products, which are nicely managed by apps, right? You can turn the intensity down, even the colors change and so on. And this is actually based, for instance, here's a good example on NoSQL-based Google Cloud data stores, which are high performant. And for Philips, of course, the benefit is that, they serve this in a very scalable fashion. This is an example of a number. It's probably much more these days, 200 million transactions per day of users that want to have their own home experience better. And of course, it also enables Philips to say, if you use the Google Cloud, as I said to you before, they don't have their own IT infrastructure anymore, the engineers working on it. So many of these people can be rather focusing on the real product development. And Philips giving, of course, and the interesting, advancements that you see also with Philips in this particular area. If you go shopping somewhere, and maybe perhaps again Elko or somewhere, then of course you see lots of these products and they're more incredibly used. Behind it is the idea of the backend, and you never know how many people use the Lightning at what time at the day, internationally. So this is also something where you need a backend for Philips that is really scaling instantly. For whatever reason, sometimes in some point in the world, there could be lots of people suddenly needing, this Philips and big peaks of usage. And so you see here processing 25 million remote Lightning commands per day. And you see some other benefits here where, 10 times the scale of other similar projects. And then not only this, with 1/10 of the workforce, right? If they maybe run the platform themselves. So there are big benefits in this and using it. And obviously, the usage experience of the users is key. And if you manage this well, then of course more and more people will buy it, like we have seen probably here in Philips, but we also see it with Angry Birds, that this game became so popular. It's not because it's so boring to play and has always issues, because it was always interesting to see the initial games scaling up very nicely, no problems in using significantly and so on, like maybe other games that didn't use much cloud features. So from the NoSQL features a little bit, again, it should fill basically a whole course in the university. You can have much more easy application development with it. You have no big schemas. In SQL, you start usually with a schema, name, surname, telephone number of users, etc., etc. Here you have rather a kind of key value idea, right? And you have different basically ideas how you would name this where you would have in a cloud data store maybe some category of an object, what you would say would be a table. One object would be then one row within the table in a relational database. And then for each of the objects and the data for an object, you have a field in the row. And some unique ID would be the ID of the user or so, or Kennital and Iceland primary key. And this is something where the cloud data store is a little bit doing similar things. Obviously, it's still a database, but it has basically not this kind of string, or let's say this interesting schemas, and then also this store procedures, triggers that you can have in SQL. So it's a different way how relationships are described in a way, and I'll bring you some examples in a moment. And this enables you really then scaling up and scaling down. And here's a good example of, a typical user, where you would say, okay, in an SQL database, I have always a key, I have always the email, always the ID. But you see that users, for instance, when you see Facebook, right, it's a good example. Users give you different information. Some people are just having the email. Some are very open-minded, giving, first name, last name, all the different, let's say, phone number information. So hence the information collection is coming again, like you see here, not only very distributed, also very different. And the elements we have seen before in one of the slides that you connect now to it are these NoSQL databases that gave rise to, the Firebase that we have seen, which is a NoSQL cloud data store, for really being active in real time so that you have real-time analytics, what's happening. Then, Firestone is optimized as a Lego block really for mobile and web application data, and et cetera, et cetera. So Cloud Big Table is, of course, something which is also widely known, NoSQL wide column database, and the column database we will review shortly. And of course, still, again, think about Cloud SQL is still there, right? MySQL Server, PostgreSQL. This is also used in applications. Here, I don't want to speak against that. I was just saying for some of the application developments, the NoSQL stores are much better in performance. So maybe start a little bit with Cloud Big Table, which is quite known and was also one of the services that made it, say, Google a little bit, prominent, because it can really scale to petabytes of data, right? It's a little bit similar with the idea of Hadoop distributed file system, putting a Google file system close to it. But underneath is really, it has many similar elements of traditional databases, of course, but it's more a string-based approach that we have seen before with the users, a little bit in the kind of pseudo idea how this database is looking like, with a name, phone numbers, and so on. And here you see some again benefit why you would do this, right? So you can see new data relationships and insights. Basically its performance still with 30 years of news data that you can really quickly access. Again, think about read only. SQL is really driven also by write, and think, okay, SQL, we need the field phone number always. So we have a check on it. If that is filled in the big table, you wouldn't care necessarily and would say, okay, there's not this kind of thing. So hence, this is a real big Lego block, which you can do many different things in app development. And here's an example, but we had it also before, where you can have, let's say, machine learning for finance application, where you put, again, this different Lego bricks I talked to you before together that are offered, let's say, by the Google App Engine. And the streaming of the financial information and, time series processing with the so-called data flow service need to be stored somewhere where then Cloud Big Table can be there. But then from there, it's a sort of platform where you can do now many different things, right? You can do the processing with Dataproc. If you remember, these were the world of Apache Hadoops, Sparks, and so on. You can do traditional data analysis, summary statistics, and so on, or you do cutting edge machine learning with the AI platform. So these are all different areas where you can, basically use these different NoSQL stores, but there are also, of course, queries or typical cloud data storage where you can do different things with in the application space. And they all have their, unique selling proposition. So let's go briefly, quickly through these different stores. And by now you a little bit see this here when you have the contents, which are sort of the key then and an anchor from the site, basically looking backwards on a domain name, you can have a reversed URL in a way also for storing web pages. What was done essentially by Google also for the quick search that you remember, right? Was Google was once a beta service and didn't have many services, was just a search engine. So many of the concepts and so on were rising from that. And when we now compare this, I mean, we have done this already. You see basically here some overview where really good for structured data. You will remain for SQL databases, but in many of the apps that you develop, there's really unstructured data a lot these days and web-oriented data. Think about Facebook, social media platforms, all different data. Some people post a lot, some people reel a lot. So basically, there are different ways how you use these, and this is nicely supported. And some of them, are very much known probably to you. There are different varieties of them. One is a column-based approach from HBase, for instance, or MongoDB, CouchDB on document-based. They all have the same idea of not tracking maybe all the different information exactly as a schema. And, have key value-based services maybe used with Apache Cassandra, where you use some JSON notations here and there, or graph-based approaches with Neo4j. Just saying that the old approach of doing everything always with SQL is today not anymore, necessary and also not used in, high performant applications, especially for those that scale to big data and, basically are accessible over the web. So when you see this conceptually, like HBase, for instance, we have touched on this before in Apache Spark a little bit. You see from the conceptual point of view, you still have sort of a typical database view of a table, but there are lots of empty fields because the physical view basically says that the empty fields are not really stored like in a relational database, right? So in HBase, you would rather see it like this. So these fields that you see here are not really stored. You have row keys, both of them, but sometimes the column family and column family anchor and contents will be basically stored differently so that you save the space, you save essentially the whole idea. With this, however, you see that not every, element in the table has then all the information, which makes it differently. For MongoDB, they have this JSON I was alluding to, a very simple notation, how you do now basically, let's say the data, right? You see also that the data can have different information, right? Someone is in level 5, some other has a phone number. So you have different types of documents that you can easily link to each other following, let's say, the JSON notation. And this is something what usually in 101 computer science is shown, this object notation. So I don't go much into detail in this, but you see that, this is nice how you can specify certain documents, what they should entail, what field they have, and also know you're very quick, creating of documents that are not so much, let's say, strict like a schema you would have in the SQL world. Then, when you have Apache Cassandra, another type of database, it's more key value based example, which is used by very many, applications we will move to a little bit. Then you have this primary keys as hash values, but the interesting thing is it's already also distributed by design. You see, you can nicely roll that out through different, let's say, nodes, right? There's different users, maybe user information, again, demonstrating one idea, which is also not so easy in SQL databases to do, to roll them out, right? To really go to a geographically distributed idea of maybe also having different nodes in different countries, depending on user experiences and so on and so on. So I want to summarize a bit because it's just a short lecture. We usually would have much more time for it. And for all of those that want to do this and want to learn more, there's also a full version of the PAAS lecture from last year on YouTube if you want. This year we had to do it a bit shorter because of a large industry project. But you see, you cut the coding time, you have lots of development capabilities out of the box, including the whole lifecycle support, machine learning. It's all automated, adding more storage, reducing storage to cut costs. You can do this on multiple platforms usually. We didn't discuss that yet. So iPhone, is there, but also many other providers of, phones today. So where you maybe have also some idea of managing your app across these different platforms, maybe even including websites. And they're basically quite affordable because you have this pay-as-you-go model. You can, scale up, scale down to your needs. and have also sophisticated tools that maybe can also give you more incentives to learn something about your users, how they play the game, for instance, to also, let's say, alter your game into certain directions, making it even more popular. You can also geographically distribute often your development teams with it. It's all in the cloud as well to build it. This software development kits here, for instance. We will talk a little bit about in lecture 13 how this is more supports with kubelets, Kubernetes, containers, right? How you build then apps and so on. But the developer tools you see here are quite strong, you know, from everything you need essentially as a cloud developer. Just some other examples maybe here for, you know, Google Cloud examples, how these different systems are used. Again, we had this, you know, data proc already in some of the earlier lectures with Apache Spark, Apache Hadoop. You know now both how they work, very geographically distributed. And you see that Vodafone Group, for instance, here you see an example, 600 on-premises Hadoop servers to the cloud. So they had their own cloud in Vodafone, 600 on-premises Hadoop servers. But it was more cost effective for them to go to the Google Cloud. And, you know, you see basically 226 models running in production daily. And to roll out to Doodle took them just basically 2 months, right? And with this, they're scalable. Twitter is an old example, you know, it's now called X, but also there you have examples how they now use basically moved from their own on-premises Hadoop, so their own installation, to the Google Cloud, and also was cutting costs and having access, of course, to many different services, which is also a very key thing. I promised you this example of Angry Birds, which I think by now I quoted often and is very obvious. Here's an example that, you know, basically after the launch that, you know, this was a skyrocket application. They did a football game before and it didn't work. So you never know, right? If your game is really skyrocketing. And, you know, by now everybody knows here, I think in the course that Angry Birds is extremely, you know, successful. As one of Google's Play's best games, basically. And with this was more, you know, basically advertised. And by now we have movies, we have different apps, right? And this is all basically because they directly moved onto the Google Cloud, had the chance of scaling up to 140 million downloads, right? Very quickly. And this is, of course, something where you have more revenue channels, in-app purchases now, even increasing your revenue. And if you look behind the scenes, Memcache API was, for instance, used to provide temporary high-speed data access. You know, this is something what you always need. If you do Angry Birds, you will know you shoot, you know, the bird through the level. And it's all basically distributed as well. And you have, you know, many different aspects, which makes it quite nice to use a Memcache, right? Where you think again and again in the levels that you have in these apps, there will be things coming again and again, and temporary values, your rain, yes, no, and so on. Of course, many of these things go down how this app is played, but you see that instead of creating their own software, they just use the Google App Engine and the Memcache services. And I can go on and go on, and unfortunately the lecture time is already almost at the end. I just wanted to make the point and connect to some of the earlier lectures. Natural language processing, you know, also the realm of large language models is now there. You can bring them in, like for instance, for sentiment analysis in your app, or for other, you know, analysis of data, very easily, having other Lego bits and pieces that you see here, text to speech, cloud translation, cloud natural language, speech to text services. All of that is already there as Lego bricks. You just have to bring it to your own application. And with this, I'm also closing here, because in the end, I could sell you much more PAAS services, but I think you can look them up your own at the different cloud vendors. Just here, I would recommend you this video where, because it nicely summarizes some of the PAAS advantages. If you now, you know, go to the job world, you have a job as an app developer, always thinking about maybe there's something in the cloud for you. Matters not if it's a Google Cloud or other clouds, but you know, this video gives you quite good positive benefits. We close then also with the platform as a service level today, but we'll also continue next time with the software as a service level and the next level. Talk to you then.